Thousands of years ago, a giant owl, an extinct rodent, and a solitary burrowing bee crossed paths inside a limestone cave. The result of that encounter sat completely hidden in the dirt until a recent excavation nearly threw it away. This unlikely meeting happened in Cueva de Dicono, a cave located in the southwestern Dominican Republic. Researchers were conducting an emergency rescue excavation, pulling fossils from the ground just before the site was scheduled to be destroyed and converted into a septic tank. When paleontologists bring fossils back from the field, standard protocol is highly rigorous. Every crevice, joint, and cavity is washed, scraped, and scrubbed clean of dirt, so researchers can properly study the skeletal anatomy. But while working on the jawbone of an extinct capybara-like rodent, a researcher stopped. He noticed the sediment packed inside an empty tooth socket wasn't the chaotic, rough mud you normally find in a cave. It was a perfectly smooth, concave wall. If the team had stuck to standard procedure and scrubbed that bone clean, they would have permanently destroyed this specific evidence of a biological relationship we've never seen before. At first, researchers jumped to a familiar conclusion. Spurred by a friendly academic challenge to publish a paper in a single week, they assumed these smooth dirt structures were simply ancient wasp cocoons. But that hypothesis quickly fell apart. Wasps build their nests by mixing chewed plant fibers with saliva, which creates a distinctly rough, papery texture. The walls inside the fossilized tooth sockets were highly polished. To figure out exactly what they were looking at, the team abandoned their one-week deadline and placed the fragments under a scanning electron microscope. The images revealed compacted clay lined with a waterproof wax secreted by the Dufour's gland. That chemical signature belongs to a very specific architect, solitary burrowing bees. The team hadn't found wasp cocoons at all. They had discovered ancient bee nurseries. To understand why a bee would choose a dead animal's jawbone to raise its young, you have to look at the surrounding environment. 20,000 years ago, this region of Hispaniola was a jagged karst landscape, a rocky terrain lacking the deep, stable surface soil that burrowing bees require. With no loose topsoil outdoors, the only viable mud for nesting was the clay-rich silt washing into the dark, sheltered recesses of Cueva de Dicono. But the cave was already occupied. A species of giant, now extinct, barn owl had been using it as a roost for generations. After eating local rodents, the owls regurgitated dense pellets of undigested bones, carpeting the cave floor in a thick layer of skeletal remains. When the bees moved in and began digging into the cave mud to build their nests, they collided directly with this massive buried bone graveyard. This diagram shows how bees adapted. Instead of digging through bone, they used empty tooth sockets as armored nurseries. Returning across generations, females built new mud chambers directly inside empty ones, stacking them up to 6 generations deep like Russian dolls. The biological waste of an avian apex predator provided the exact structural solution to a geological housing crisis for a vulnerable insect. This specific behavior is entirely new to the paleontological record. It earned the discovery of brand new trace fossil classification, Osnidum Almontei, which translates from Latin to nest in bone. Beyond the biological oddity, this discovery serves as a blaring warning siren for vertebrate paleontologists. The standard practice of aggressively scrubbing every cavity of a fossil risks erasing fragile ecological evidence before anyone even knows it's there. The packed dirt inside a fossil is a microstratigraphic archive. It holds vital data about ancient ecosystem interactions you cannot get from studying bones alone. Cueva de Dicono narrowly escaped being bulldozed. Caribbean karst caves like it act as fragile, irreplaceable hard drives that record the lost history of ancient ecosystems, and protecting them is the only way we can continue to read those files.